Hello friends, welcome to my channel DataMaking. Okay, in this channel I create videos on big data technologies like Spark and Hadoop, and also I create videos on programming language like Python, SQL and Scala and Java. And also I'm going to create videos on machine learning and deep learning. So please subscribe to my channel to get more technology videos. In the last video we discussed about introduction to HDFS. Okay, what is the need of HDFS and how the HDFS works and what are the benefit we get from HDFS. So we talked about something blocks in the HDFS, something called blocks in the HDFS, which is already there in the normal existing file system. Okay, so we'll understand more about the blocks usage in the HDFS. Okay, in this video. Okay, so let's start with the introduction or details about the blocks usage in the HDFS. Okay, so if you look at your local file system, say example I am having a Windows. Okay, so if you have a Windows operating system, okay, so you in the Windows operating system also, like the file system which is uses NTFS, right, the latest file system. So what they use is they also internally use the blocks whenever you store the file into HDFS, in your local system. Okay, so it splits your data when it stores in the hard disk. It splits your data into small blocks. Okay, the block size of 4 KB. Okay, so what happens is, say example I create a small file, okay, which is of around 2 KB. Okay, so if 2 KB is my file size, actually what it does is the Windows operating system internally the file system allocates creates one block. So block will have a size of 4 KB. So it will use 2 KBs of my file content size is 2 KB, but remaining 2 KBs will be unused. Okay, so that space cannot be used by other files. Okay, so because of that you actually will tend to use a lot of unused space in the local file system. Okay, so that's how the local file system has been defined. Okay, so how we can overcome in the HDFS, we'll see. Okay, so if you look at the block size in HDFS, okay, if you see the block size in HDFS, so in Hadoop version 1, the default block size was 64 MB. Okay, and in the latest version 2.0 it is 128 MB. Okay, so what happens is whenever you store a small file in HDFS, okay, you just move you copy or move to the HDFS. Okay, whenever you try to move copy the 1 MB file to HDFS. So okay, so by default the default block size is 128 in the Hadoop 2.0 version, right? 2.0 version. So it will create your block with the 128 MB, okay, block. So your file will be converted into block, right? So your file is 1 MB only. So it will use 1 MB as space. The remaining blocks, right? The remaining free space will be used by other files also. So it will not make it as unused, because internally what it does is the HDFS will use the local file system only, because we saw in the last session also the HDFS is another layer on top of your local file system, like in terms of Linux it's the ext4, right? So internally it actually converts your file into blocks as HDFS blocks of size 128. When you store in the local system, all your blocks will be stored in a local system. So it will store as a local file system blocks. So it will store in your in continuous manner. Okay, it will store it in next to each other. So the idea, the key point to take here is, so it will not actually create the 128 MB for a small file. So it will create a block, but the remaining free space will be used for other files also. That's what you need to understand here. Okay, that's what I mean to say here. So you, in Hadoop version 1, so the block size was 64 MB. 2 in the Hadoop version 2, the default block size is 128. Okay, suppose if I'm trying to store file1.txt. Okay, so so file1.txt, if I want to store it in HDFS. So example, it is of more than 380 or 400 MB. Okay, more than 400 MB. Okay, say example, it is a 400 MB. Okay, so what happens is you will be getting it. So what it does, it will actually split your file into 400 MB file into the fixed size of blocks, right? So I'll get almost 4 blocks. Okay, so what it does is it stores block 1 in the node 1. Okay, and it has to replicate that block, right, for the data loss or the data failure. So it will store the another copy of block into node 2 and another version in the node 3. So whenever this node 1 goes down, so it will actually either pick from node 1 or 2. Okay, so similarly, so all the blocks are getting replicated and stored in the different nodes. Okay, so this is how the blocks will be stored. So you can ask me why we are having actually blocks why we are keeping a block size as 128 B, not the 1 MB or 2 MB. So what it does is when the HDFS is designed in such a way that, so when you store a new big file, okay, so the read and write is faster. How it is faster means the blocks the block size, whenever the block size is bigger, so internally the local file system will store your blocks into in continuous manner. So it will store next to next each other, so that the disk head need not to seek again and again for reading and writing. So in a way, it is actually giving you flexibility to read and write in an efficient way. That's how it improves the write and write faster in HDFS. Okay, that's why we are using actually a bigger block size. Okay, so basically, and also you can when we come to the other processes in the HDFS, we'll know actually why we should not have smaller files in HDFS. We should have bigger file HDFS. We'll understand that. So there is some overhead to the some process, that all things will I will learn it. So in the okay, I'll just stop it in this video. I want to keep it this video short. So in the next video, I will start how to work with HDFS. Okay, and we'll learn more about on that. Okay, thank you so much, friends. Please subscribe to my channel to get more technology videos.